Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Izzy Lawrence. On this week's Terrible Lizards, we are absent of a guest, I know, but don't worry, because we're going to be talking about the most important thing in the world. That's right, food. Join with us on a journey through a dinosaur to see exactly what it's been nomming on. A nomming on. Hello and welcome to another episode of Terrible Lizards. I am Izzy Lawrence, and across from me on the internet it is Dr. Dave Hone.
Hello. Well, I never know what to say because obviously we've been talking for the last 10 minutes before we started recording, so it seems we say hello because I'm clearly not as professional with you about doing this stuff.
We were talking about each one of our patrons and how much we love them. That's what we were doing. And we're having a look at your questions. Do keep sending us your questions for our final episode of the series, which will be our questions episode, so please do that. But before you go, actually I've got a really good question about dinosaur food, because you didn't cover this in your dinosaur food episode. So how do you know about dinosaur diets and blah blah blah? Because that's what we're going to do now, so you won't need to ask those questions, so don't write those emails yet unless we forget to cover it, in which case write those emails because we're probably going to forget to cover it. And so yes,
or I say something slightly ambiguous or contradict myself, which is what usually happens.
Usually what happens. Hey, it looks like this fossil ate other fossils. So I mean, what would you do if you found a dinosaur that actually ate fossils?
Well, they probably wouldn't. Stone is difficult to digest and not very nutritious.
Gastroliths.
Well, yes, but that's swallowing rather than actively ingesting for the first part of your diet.
Fair enough. We've covered the fact that we've got carnivores and we've got herbivores, and there isn't really a true herbivore apart from a weird bird that eats leaves.
There are many herbivores.
There aren't many vegan animals.
Well, if you're going to be
they're all omnivorous.
Well, I was going to say, if you're going to be that extreme, it's true of carnivores as well, really, because the lions and things like this, they eat lots of viscera and they eat those partially digested plants that are in the stomach, and that's actually pretty good for them. They get lots of stuff that they can't get anywhere else.
We got a fern delivered to our door yesterday, right?
I feel we've gone off kilter already.
When we opened the box, no ferns. Yeah. They were in the cretaceous. Plant, yes. They had ferns, right? The moment we opened the box, before we opened the box, Vincent, my cat, was all over the box. The moment we opened it, he stuck his face in and started eating the fern. That
is something that I thought was the prerogative of Garfield, and I thought it was made up because ferns are horrible things to eat and quite toxic, and therefore it seems bizarre that a cat would ever eat them.
He's quite sleepy now, so it might work. But no, they like grass, cats, quite a lot, because they need it for their digestion.
It is fair to say that overall there's, if you're going to be pernickety about it, there's pretty much nothing which is actually a true carnivore or a true herbivore, in the sense that carnivores that never eat any kind of plant and herbivores that never eat any kind of animal. The reality, of course, this is biology, somewhere in between, it's a continuum. But yes, you have what we often call hypercarnivores, things like great white sharks, ripping chunks out of whales or stuff like that. They're eating almost exclusively meat in that regard. And folivores like hoatzin, which we talked about before, the big bird from South America, which just eats leaves. Yes, they're going to be consuming lots of little insect things as part of doing that, but they're very, very, very herbivorous in that regard. What we don't have many of for dinosaurs is omnivores in that very kind of badgery type way. I think badgers are really good. Well, badgers I think are really quite good for, they eat mushrooms and they'll eat tubers, but they'll,
hedgehogs.
If they catch mice, they'll eat them, or birds' eggs, or a lizard, or certainly worms and beetles and things like this, and, clearly have a very mixed diet. There's not a lot of evidence for that, or at least I don't think there's any real evidence for dinosaurs doing that. There's a few taxa whose diet is either extremely uncertain, or some people have argued carnivore and some people have argued herbivore, and maybe the reason for that is the truth is somewhere in between.
Let's start with carnivores. How can you tell what type of animals carnivores are eating?
Well, you often can't, and this is obviously the real challenge with this kind of stuff, and which is why we end up across these many episodes of our series of me saying, well, we don't really know that, or we can't really know that, or it's very hard to tell. I mean, going back to your very basic pre-question, how do you even know if it's a carnivore or a herbivore? That's harder than you might think. So the troodontids, which we talked about, I'm sure we've mentioned this before, have these rather unusual teeth, which are recurved like so kind of like a shark's dorsal fin, they go up to a point and then curve back on themselves, like we see in just about any theropod. Almost all theropod teeth are serrated up along the front and the back edge. The front serrations barely exist, and the back serrations are absolutely enormous. They're really, really big. Even in huge things like T-Rex, which doesn't have many teeth, you know, we're normally talking about like 5 or 6 serrations per millimetre. So they're absolutely tiny. And then in some troodontids, they're like 2 millimetres long. So they're 4, 5, 6 times the size of what you see in giants like tyrannosaurs. And troodontids are really tiny. You'd expect them to have even smaller serrations. And one of the groups of animals that have teeth with really big serrations on them are herbivores. Things like Iguanodon has teeth with really big serrations on it. So you can see why early on, when troodontids were very fragmentary and we didn't really know what they looked like, that people went, maybe this thing's some kind of, it's a theropod, but maybe it's transitioned to herbivory and it's gone for these giant serrations because they're good for cutting through leaves rather than meat.
Yeah, so that's why you see serrations is just on for, like, I'm thinking on a saw, they work a treat getting through wood.
So yeah, serrations are good for basically cutting through things, whether that is muscle fibres if you're a carnivore or plant fibres if you're a herbivore. You can see that they're probably doing a similar kind of job in a similar kind of way, but they're usually optimized in different manners, which is why you tend to see these finer serrations in carnivores and broader serrations in herbivores. It's worth saying, perhaps, in fact, that if you look ancestrally, like the earliest dinosaurs and indeed their ancestors, like groups like the dinosauromorphs, and indeed crocodiles going back to, you know, not modern but ancient crocodiles, a tooth, you know, this recurved tooth, shark's fin-like tooth with serrations front and back is the ancestral condition. They all had this, and then at various times got modified in lots of different ways. Again, early pterosaurs have this as well, to a lesser extent, because they're kind of weird. So yeah, curved serrated teeth is absolutely just a thing for dinosaurs. It just then obviously gets incredibly and dramatically modified in lots of entertaining different ways, but it does mean that you do get some intersections like this where it's kind of hard to tell them apart. And similarly, things like Oviraptorosaurs, which we talked about in a previous episode, again, big sharp beak and not a lot else behind it. Well, that could be good for several different things, and it's really hard to know exactly what.
The curved nature and the shape of the teeth, that reminds me a lot of those repeating patterns that you get in mathematics.
Mandelbrot sets, yes.
Yeah, and reminds me of sort of, you know, how you get these spirals occurring again and again in nature because of, like, snail shells and that sort of thing. In my head, because we're describing it now rather than looking at it, but does it sort of come across like a Mandelbrot set?
No, so the serrations are usually quite different shape to the tooth itself. They're not like a lot Mini you get teeth. With saw teeth. Yeah, it's not another recurved shape. They're often little, almost kind of little domes or little semicircles. They're not actually that complicated or have some other little subtle hook to them or something like that. For the record, the troodontid ones kind of look like that, but most theropod ones don't. They're pretty simple.
I seem to remember having these when my front teeth came through because I had little dumples on my front teeth and then they smoothed off. Do you remember that? Your milk teeth, when they push out and your big teeth come through, they've got little dimples.
So A, I don't remember my teeth coming through. That was 30 odd years
That was
ago.
A big event for me.
And B, I doubt whatever it was that you had is similar to dinosaur tooth serrations.
I think it's very similar. It's to help it get through the gum.
Yes.
But talking of the teeth, are all dinosaur teeth, like, do they all recycle? Or are there some dinosaurs which are like us and keep their teeth for life?
I don't think we know of any that did that. So the tooth replacement thing in archosaurs, so including crocodiles, including pterosaurs and a few other things as well, it appears to basically be universal. Short of having a beak, they grow their teeth out on this, almost continuous cycle. Again, some super weird exceptions. Tyrannosaurus rex, the, inverted commas nanotyrannosaurus, which we talked about before, the juveniles have more teeth than the adults. If you think that's weird, there's a thing called Limusaurus from China that I helped dig up and describe. And Limusaurus is the oldest beaked theropod that we know of. It's from the Middle Jurassic.
Whoa.
And it's from a group of ceratosaurs. So that's a group which are of a very early branch of theropod evolution and include Urobellisaurs, and you get into the far end of ceratosaurs. So that was already very, very weird. We had this super early herbivorous theropod, and that's got gastroliths as well. So you mentioned gastroliths, so stomach stones to help grind stuff up. So that's a very, very convincing argument that Limusaurus is this super early beaked herbivorous ceratosaur. We got really quite a lot of specimens of Limusaurus because they're from these mud pits that preserve lots of individuals together. We regularly find multiple individuals together. together, the juveniles of Limasaurus have teeth. So the juveniles have teeth, but the adults have a beak.
Interesting.
Yeah, they're doing something weird. And the obvious question is, well, what are the juveniles eating and how do you transition from beak to teeth? And because obviously we don't have one that's like caught in the act of dropping its teeth. Did it happen quite quickly? It's perfectly possible that it took weeks or even months, speculating wildly for no reason whatsoever. Maybe they went into hibernation and, they had 3 or 4 months where they weren't doing anything. And so that's a perfect time. You've got more than enough time for your teeth to fall out, no new ones grow, and a beak to start forming. I mean, who knows? But yeah.
Maybe their parents cared for them for a long time.
I mean, some of these juveniles are quite sizable. We're not talking about hatchlings.
Yeah, but you see some of the eagles left in an eagle's nest, but when their parent is just a big...
Yeah, and they're 3/4 size, yeah.
Yeah, and you're just like, seriously, they could easily fend for themselves. Like, no, Mum, bring me food.
Yes.
But I might be identifying a bit there.
Yeah. So yeah, teeth are a very good place to start. If you see really big, fat, blunt teeth, they're probably good for grinding things up. If you see extremely sharp teeth, they're probably used for eating meat. If you see teeth that are very rough, or if there's loads and loads and loads of teeth or things like that, they have some kind of good shearing mechanism going on and lots of abrasion, teeth rubbing on teeth. That's an indication that they're trying to mess stuff up between them. These are all reasons to think that you've got a herbivore. And in the grand scheme of things, there's this idea that reptiles have simple teeth, which I think has reasonably come about because if you look at it, living reptiles, with the obvious exception of snakes and their giant fangs, it's a pretty uniform set of teeth. If you look at, I was going to say, if you open the jaws of a lizard, but not too many people have got a lizard knocking around that they can open up. But, if you just Google lizard skull or reptile skull or something, you will see crocodiles, the teeth are largely the same. Komodo dragon, the teeth are largely the same. Chameleon, iguana, the teeth are largely the same. And so there's an idea that mammals have complicated teeth and reptiles don't. And that's really not true.
And by complicated teeth, we mean that we've got incisors and we've got molars and different teeth in our mouths.
Well, two different things going on there, actually. So first of all, yes, multiple different types of teeth within the jaw, which, yeah, we absolutely have with our incisors, canines, premolars and molars. But also, the teeth themselves are quite complicated. If you look at our...
roots.
Well, I was thinking more of the molars and premolars, have these multiple cusps. The tooth itself is quite a complicated shape with multiple different bumps and dips. And while it's highly modified, if you look at that, something like a lion, again, for what they call the carnassials, which are the equivalents at the back of the jaw, multiple big lumps into kind of almost a maple leaf-like shape, kind of projecting multiple lines. And reptiles are just, it's a peg or it's a lump or it's a spike. And dinosaurs are often neither of those things. The teeth individually are quite complicated and they can have multiple different types of teeth in the jaws.
And is that because, is the idea that they're simple simply because they don't have the movement in their mandibles like we do, so we can go side to side as well as back up and down and back and forward a bit?
Not necessarily. I think it comes from just, degrees of specialization. I mean, pterosaurs have very simple jaw mechanics in terms of being extremely simple up and down, and yet you see, I would argue, the most extreme variation in tooth size and type in pterosaurs, even far more than you see in many dinosaurs.
Well, we talked about Rhamphorhynchus with its weird,
Well, Rhamphorhynchus has got so it's got a beak and then it's got big spiky teeth, but its teeth are at least fairly similar along the jawline. They get smaller as you get further back, but that's about the only real difference. But if you think about something like Dimorphodon, let's do our classic fun bit from example. Break the name down. Two. Morph.
Shape.
Don.
Tooth.
Yeah, 2 types of teeth. Dimorphodon's name literally tells you that it has 2 different types of teeth in the jaw. It has these big spike-like fangs at the front, and then it has these really, really tiny teeth at the back, but they all have these multiple little cusps. So 2 completely different sets of teeth, both of which are doing different jobs. And again, the back teeth they're not as complicated as our molars, for example, but they are complicated shapes. They are not simply little spikes. So yeah, complex teeth abound. And therefore, again, we're not talking about pterosaurs today, but again, working out the diet, it's not as simple as they've all got this one type of tooth that does this one job, so they're probably doing that with it.
I was watching some cool, and he's been on our podcast, so I need to support Chris Packham where I can. I was watching Winter Watch, and they did a special, I think they were looking at oyster catchers. I think they were looking at, might be a type of woodcock, I can't remember, but that sort of shaped beak. And there's these ones which can manipulate the end of their beak.
Yeah.
So So the actual top of their beak bends, and that's freaky.
Yeah, there's a couple of things that can do that. Oyster catchers are particularly, I think it's woodcock, but I don't know because I'm not that good at those.
I think it was a woodcock.
But oyster catchers, I know, their beaks vary, not just like between populations or as they grow, depending on what they eat. It varies per individual as they shift their diet. So if they start hammering on bigger, harder shelves, their beak will shorten and get thicker. And if they start probing into sand more, their beak will lengthen and become thinner.
Wow.
So, yeah, again, but, you know, animals do some really, really cool, some really, really weird things. And it's also a classic trap when we start arguing about things like what is a species. People go, oh, it's got different teeth, so maybe it's a different species. Well, maybe it isn't. Or maybe it's just a weird one. Or maybe it's literally, if we came back 6 months later, had it not died and been fossilized, its teeth would look like something else, which is exactly what Limosaurus has gone and done. If we'd only ever found juvenile Limosaurus, we would have not the faintest idea that the adults were toothless.
Wow. Okay. So, got teeth.
Yeah.
So you can kind of get an idea of what they're eating, but don't rely on the teeth. If you found a tooth, don't assume.
Yes, but we can do more things with teeth. So the first thing you can do is look at the microwear. So enamel is, you know, hilariously strong.
The hardest thing.
Yeah, pretty much. But it will still be scratched at the microscopic level by almost anything with any kind of, you know, resistance. It's not perfect. Bones and shells and things like that will tear it up. Meat fibers, just the very fact that, you know, you've got relatively strong little bits of sinew running through is enough to scratch enamel in carnivores. And of course, all kinds of things like hard nuts and seeds and wood and stuff like this will scratch the teeth of herbivores.
Lego, separating Lego.
That'll do it. But these all have fairly characteristic patterns in them. You can look at the teeth of deer and antelope and sloths, and actually sloths don't really have teeth. But well, they do, but not chewing the same stuff in the same way. But you know, kangaroos. There you go. You know, very different animals with very different ancestry. But if they're processing plants, you'll tend to see the same types of scratches on their enamel, and that will preserve in the fossil record. And people have absolutely got hold of dinosaur teeth, and you need to do a very high resolution
magnification
scan of them, but you can see those scratches, and that will give you an idea of the kind of things that they are biting and feeding on. As ever, there's some issues with that because obviously their diets might be changing. The teeth can get bashed up when they're sat in the fossil record. You can imagine the teeth being sat in sand grains and washing around for ages. That'll give it way more scratches than it will ever have got from what it was doing in life, etc., etc. But there are definitely some indications you can pull out from that. So you can start looking not just at the gross shape of the teeth and the serrations and the patterns of it, but also some microwear. And then we can start looking at the isotopes as well.
So you're comparing dinosaur teeth to modern animals with similar wear and tear and just going, there's like a lion tooth that's eating gazelles. Ooh, this velociraptor's eating gazelles. Maybe Protoceratops are gazelles.
Well, so it's more that, yeah, if you look at things like, I mean, I'm just naming things rather than thinking of specific paper, but you know, if lions and crocodiles and monitor lizards and wolves are all getting the same kind of marks on their teeth, and sharks say, then that's probably to do with meat rather than anything to do with quite how they bit it or exactly what they bit or where they live. And that's the kind of thing that we're looking for, is these almost universal patterns, because that's, you know, again, not biased by size or biased by location or biased by evolutionary history or biased by enamel structure. So you can fix that. And then with isotopes, so we've muttered about isotopes before, but
I don't know if we have actually. We've mentioned them, but I don't think we've gone into the science of isotopes.
Yeah, because I don't know it very well.
I know. That's why I had to do it too.
Yeah.
It's just like, well, your carbon-14 is a certain amount of radioactiveness, and you can count the number of pips on the thing. That tells you roughly when it was around.
Yes.
Sort of thing.
So elements which obviously make up everything have protons and neutrons in their nucleus, but the neutrons can vary in number, and that will give you what is called an isotope. So an individual atom of an element which is heavier than the normal one, whilst being stable. The classic one is, carbon-14, which is heavier than the normal carbon-12. But this is true for all kinds of different things.
And you can tell how old it was by ice cores.
Yeah, well, that's getting into carbon, but first of all, though, we're getting horribly off topic.
We are, sorry.
We don't carbon carbon date dinosaurs. Carbon dating is good for a few 10,000 years.
Because that's the ice core
Dinosaurs are not carbon dated.
I know.
Yeah, quite. But what's interesting biologically about isotopes, because they're present absolutely everywhere in all kinds of, in huge numbers, but various biochemical processes prefer one isotope over the other. I think it's the lighter one, but I can't remember. Almost certainly because it's the more common one, but it doesn't really matter. The point is that the inverted commas wild isotope ratio will be different to what you would find in a plant, because the plant will select one isotope over the other. So it will get isotopes of, say, oxygen from the air, and it's picking them up, we'll say, for argument's sake, in a ratio of 99 normal ones to 1 heavy one. But it prefers to use the normal ones, and therefore you'll find 999 normal ones to 1 heavy one in its tissues. And that means if you can measure that difference, you can tell that a biological influence has happened on something. And actually, that goes through food chains because that happens at each level.
Yeah, and probably it's more extreme when it's a carnivore.
Yes. So the ratio from a plant to a herbivore and a herbivore to a carnivore is different. And so you can spot carnivores from herbivores based on those isotope differences.
It's like mercury in your sushi.
Yes. The thing that's quite important about that is isotopes can break down for various reasons, or they do break down, but those ratios can alter for various environmental reasons and various preservational reasons. And the reason that enamel is really useful is enamel is so tough, it's also hyper stable, which means it doesn't tend to lose those ratios. And we've seen this problem years and years and years ago. I did a small piece of work with a colleague who's a real expert on this. And I said, can we do it on pterosaurs? Because there's a bunch of pterosaurs where we kept finding them in the sea, but we thought they ate on land. And of course, because pterosaurs are really rare and don't preserve well in land deposits, it was perfectly possible that these were the equivalent of parrots and were spending almost all their time on land, but we only ever found them in the sea. And I thought this would be the answer. If we pull them out and if we see from their isotopes that they're feeding on, nuts and seeds, or if they're feeding on fish, then we'd know what they're really feeding. And the results came back and they were all over the place. And the answer was, oh yeah, because these are toothless pterosaurs. We don't have enamel. We had to look at bone, and bone is notorious for going screwy. So we had things like Pteranodon. Pteranodon was one of our things we use as our baseline. Pteranodon, every bit of its anatomy tells you that it's an ocean-going animal for flying. We've got Pteranodons with fish inside them. We've got Pteranodon bones with shark teeth buried in them. We've never found a Pteranodon closer than about 150 miles off the then coastline. I mean, I'm sure they went back to land occasionally, but they're clearly going out to sea all the time. Thousands of specimens literally from the ocean. Looked at the isotopes, went, lives on land. And of course, it doesn't. Yeah. It's obvious that our results are out, but it just shows you that
it's science sucks sometimes. Experimentation doesn't always go to plan.
Yeah, and there's similar things you can do. So in addition to the fact that you can look at isotopes to see what the correct ecological term is, trophic level, herbivore, carnivore, or even hypercarnivore, a carnivore feeding on carnivores, you can also look at things like where it's getting its water from or how much water it's getting. So things like hippos, crocodiles, terrapins, fish, things that either spend an awful lot of time in water or are constantly processing water, basically have different isotopic signatures to animals that are on land. This is where we've definitely talked about it, Spinosaurus. There are Spinosaurus teeth out there which have 100% terrestrial signature, suggesting that animal hasn't been into water for weeks, if not months. That argues against it just living in water all the time like a crocodile.
Unless it was wearing a snorkel or something,
yes.
I like, there's a bit of modern, so this is for humans, so very recent, so the last sort of
I was going to say, if it's,
yeah, but you
be fun if it isn't.
because we grow teeth, and when we die, or an animal also stays, you can actually work out where somebody grew up, where they were from, by the enamel in your teeth. So you can analyse the enamel in your teeth and work out which river system you grew up in. Because
of the subtle different chemicals, yep.
There's a guy who's buried not too far from me in Reading, in Amesbury, and he hasn't got a kneecap, was born without a kneecap, and yet was born in somewhere North Italy, Germany, that sort of region. So he was like, he came all the way over, and he was covered in gold. He was a right show off. And copper knives, come on.
Nice. I mean, there's a similar stuff. So there's the same guy, Thomas Tutkin, I should mention his name. Thomas did some wonderful work on North African sauropods. And because enamel can grow in layers on teeth, he basically sectioned the enamel and was able to get into the different layers and was able to show those different environmental signatures in different layers that happened as the teeth grew.
So they're migrating.
Yes, that was the conclusion, is there's evidence for migration in sauropods because they're hanging around in somewhere else, so they're consuming different chemicals, so their isotopes in their teeth are different.
I mean, to be fair, looking at a sauropod, it has to migrate because it is massive. It's going to eat everything. That it's going to sit there, hoover everything up. It's going to have to move to somewhere, hoover everything up. It can't go back because it's going to take too long.
But you can migrate and still be in the same environment. You know, the classic one, the Masai Mara Serengeti, that's a couple of 100-mile migration that the wildebeest and zebra do, but it's still on the same plane. They're still on the same water course. They're still on the same soil type. But this is something different to that. So yeah, we've long-distance seasonal migrations in sauropods pulled out from isotope. But obviously...
Do you think they migrated the same way that birds migrate now? Do you think they had the same sort of like whatever it is that birds have? I just need to go to Africa right now.
Sorry, I thought you meant in terms of flight.
No, I didn't mean in terms of flight.
Well, I know what you're like. So
instinct.
Well, presumably, or at least it is certainly possible.
I wish I understood that a bit more, because I don't understand. Suddenly this little, I just gotta go. I'm a swan, I gotta go.
I've just realised I should have written about magneto navigation in my book and didn't. That would have been a cool thing to mention.
Oh, well.
Well, it would. Yeah, well, I know. I believe I just have. But yes, the fact that pigeons and lots of other things, navigate from basically a sense of the Earth's magnetic field. It'd be very cool if sauropods were doing that. Definitely should have put that in the book of things we don't know and probably can't know.
I'm really, really good at making Dave regret things.
Yes. Example 1, podcast.
By the way, Dave's book is available.
The things I regret doing. 1, this podcast.
Yay! He doesn't mean it, everybody. He loves you.
Oh, them. They're fine. You.
Oh, yeah, that's fine. But you're not doing this for me. You're doing it for them.
Anyway, you've got teeth, you've got your enamel wear, you've got isotopes. I mean, the blindingly obvious thing, though we haven't really talked about it, is stomach content. Animals do preserve with stuff inside themselves. This usually, of course, is actually the theropods, because although they're generally rarer, because carnivores are rarer than herbivores, what they're eating is bone, which is rather good at preserving in general, versus herbivores that are eating leaves, which we know have an appalling fossil record, let alone when they've all been chewed up and sat in acid for a bit in the stomach. So our fossil record of actual consumed material by herbivorous dinosaurs is pretty appalling. Our consumed record of bones for theropods is not bad at all things considered.
We had, in the hadrosaurs, we had shells, didn't we? I remember the hadrosaurs' shells, which was cool. They were eating wood and barnacles.
Yeah, so there's one with a load of fossil wood in it, and then the remnants of crushed up shells. It is possible at least that they are going along and pulling some bivalve shells up and eating them. Again, there are videos of deer and cows and things like this eating baby chicks and actively eating snails or mice or eggs and stuff. Certainly possible that they were doing, but a big bit of dead wood that's been sat in water for ages would absolutely have loads of clams and stuff stuck to it or boring through it. That's more likely what they're actually eating. But still, we have that.
Or they were after the good shellfish and accidentally ate the wood.
He ate some wood, yes. We've also got them with, I think, pine needles or pine cones and some stuff like that, and a few other bits and bobs. There's all kinds of pollen grains. We talked about this before,
Pollen is the plant and animal.
Pollen is remarkably resilient, but of course that's also blowing, pollen is just present in absolutely everything, everywhere, all the time. So it might be difficult to really pull that out from inside a carcass and be fairly definitive that it's been consumed. assumed, but certainly I can't think of any examples off the top of my head, but obviously if you found a real mass of something in there, particularly if it wasn't present in the surrounding beds, that suggests that animal has just been eating a load of, fruit and flowers or something like that off one tree to have accumulated that much pollen of just one species that's not in the environment. So I don't think that has been done, but it certainly could be done.
Predator traps and something like that. Weren't we talking about botulism at some point and how something could eat a bit of something rank and die?
And keel over almost instantly.
Yeah.
So that's a subtly different thing because, of course, that would only really tell you that carnivores are trying to eat a dead body, which is not a big surprise. But, in terms of consumed things, we've got a whole bunch. So I'm actually working on a paper at the moment about Microraptor because there's a Microraptor specimen with a mammal foot inside it. The paper's not out, but I'm not giving anything away because we wrote a conference abstract on this, I think, 12 years ago now.
Was it a lucky mammal foot?
Well, not for the mammal, obviously. It's the standard answer to that.
Or to be fair, the Microraptor, it didn't stay long.
Microraptor did quite well out of the deal, though, of course, it died shortly afterwards, otherwise it wouldn't be preserved with a mammal foot in it. I mean, Microraptor is perhaps the single best example of this, because we have 3 Microraptors with stomach contents. One's got a mammal in it, one's got fish in it, and one's got a bird in it. Interestingly, when the fish paper came out, it was argued as a fish specialist, and when the bird paper came out, it was argued as a bird specialist. And oddly enough, we're suggesting in our paper, maybe it's a generalist if it eats fish and birds and mammals.
Maybe, or maybe those two just died because they were starved. They died because they were poisoned by the thing they can't want to eat.
And this is the obvious problem with doing this. I mean, no one thought that Microraptor wasn't a carnivore, but we've got 3 examples now, and we don't know, was its diet 99% fish and 1% other things, and we rolled the dice and got really lucky and found 2 extraordinarily rare exceptions and only one of the common thing. And we don't know that. It's unlikely that we've been that lucky, or indeed that unlucky, but it's, we've talked about this again for the Protoceratops and Velociraptor, it's a data point. And if you extrapolate that to, this is the normal behaviour for the entire species across its evolutionary history, yes, it is probably a very dangerous idea. It's probably something that happened very common. Otherwise, we wouldn't have found it in the fossil record.
Or could it be as simple as crows and choughs or something? So you're going to have some which are, look visually as, fossils very, very similar, but are actually completely different.
They could absolutely be different species of Microraptor that specialise in different. Well, again, this is the problem. We don't know. Certainly, the one with the bird in it, I've seen. Well, actually, I've seen all 3 of them, but that one in particular, the Microraptor itself, is not very well preserved. It could well be that it's got some features that we're just not seeing that would make us go, hang on, this is a different species or a different genus.
Big net to help catch them.
Or who knows what confounding factors happen. There happened to be a dead bird that day, and so it ate it. It was eating the fish that were dead on the surface because there was a volcanic eruption, and that was what was killing everything, and it didn't know that it was going to die 2 seconds later itself.
It could have attacked something else which was carrying the fish or the bird and dropped it.
Who knows? There are so many. I mean, the flip side of that, there's the ankylosaur. So there's the same environment from northeast China, Liaoningsaurus. Wonderful little ankylosaur. It was suggested in a paper. I think it's fair to say this hasn't gone down brilliantly in the scientific community, i.e. everyone thinks it's not true.
Everybody's sceptical.
There was a paper arguing that this was basically a swimming dinosaur. It's like swimming ankylosaurs.
Oh, that's so cute.
Yeah, and one of the reasons were some fish allegedly in the stomach. I haven't seen the original specimen, but the paper actually had some pretty good photos. There are some fish around the stomach area, but...
Sometimes you get animals that eat like whales on the beach. They explode, so all their stomach contents goes miles.
Yeah, but even if they did eat them, that doesn't mean they're swimming after fish and chasing fish and eating fish. Again, you can go and see deer on a beach eating fish. That doesn't mean that they're aquatic or live in water or swim very well.
I would say you'd have to wait a while for that one. Fish. But maybe somebody drops their fish and chips, you might see a deer eat that. But I can't.
No, if you go, reindeer. I was thinking.
Oh, okay.
But even in the Scottish Highlands, you get lots of deer out on the beaches eating seaweed.
I need to see that. I need to see a deer on a beach.
There will regularly be small dead fish washing up on the tide. It's free protein. It will go down.
I got very freaked out in Bournemouth because you go to the seaside and you expect to see like all of these like seabirds, seagulls and blooming mallards everywhere. Yeah. Just having a little like, we're just on the beach. It's like, no, you're in the wrong place. You're meant to be in the ponds. You're upsetting me.
Yeah. Same thing again. All these pterosaurs that we get and we go, they're marine pterosaurs or they're lacustrine. They're from the edges of the margins and the estuaries, and it's like they could live 1,000 miles inland. It's just we've only found them here.
Found one in Birmingham.
It's a good place to get buried. Yeah, pretty much. I know the correct term for gulls is gull and not seagull, but there's a reason people call them seagulls, because they're associated with the sea, and you find them a long, long way from the sea often.
And it's to do with the type of wing, their basic wing shape as well. That's very suitable for the winds on the ocean or something.
All kinds of things. Yeah. But it's...
And they got webbed feet. What are they doing in Reading with webbed feet? That's just silly, isn't it?
Yeah.
So...
So stomach content.
Okay. Are we going to go all the way to the other end now?
Not quite, because there's a few more things to talk about.
Okay.
There are tyrannosaurs with whole bones and bits of babies in them. There are various small theropods.
Animal babies, not human babies. I'm just going to underline.
Yes. Baby dinosaur bits or juvenile dinosaur bits in them and things like this. And again, not quite the same thing, but we've got 2 or 3 dinosaurs with teeth broken off in them that have healed. We talked about that before. So it's a pretty fair indication that something was trying to eat something else.
Do we have any evidence of cannibalism? Is there any baby dinosaurs inside a big dinosaur?
There was one famous example of this which turned out probably not to be true. So Coelophysis, this lovely little Triassic thing from Texas, named huge number, like hundreds of specimens from a place called Ghost Ranch, and one of which was described as having the bones of a baby Coelophysis inside it, which later turned out not to be a Coelophysis. Oh. But we've got, I'm going to say it's Majungasaurus from Madagascar. There's some juvenile Majungasaurus bones with bite marks on them, and it's in an environment where the only carnivore we found of any decent size so far is Majungasaurus.
Cool.
So it's perfectly reasonable that that's it. We've got various Tyrannosaur bones with Tyrannosaur bite marks on them. I've described them. We've got a couple of T-Rex ones, so that's pretty much cannibalism. We've got a bunch of others which it's impossible to say what it is. So I described this Daspletosaurus with big bite marks on it. It's not the only Tyrannosaur in the environment, but it's also the most common one, so it's probably the same thing.
But is that going to be like, can you see if they're for just self-defense or if they're actual I'm going to eat you bite marks?
So with the Daspletosaurus, the reason we were happy that it actually had healed bite marks from combat, but the reason we were happy that it was
being eaten,
scavenging, is really quite neat. I think it's a really good example of how you can piece, almost crime scene level reconstruction.
Oh, crime podcasts are really popular. We should do like
dinosaur true crime.
Don't reveal it. Just go have somebody crying and then like moody music and then going to could we get a spooky detective? You got to imagine, everybody, Dave's wearing like a raincoat and he's going to the scene of the Daspletosaurus bone and he's having a good look at the bone and he's drinking too much and his boss hates him. Go.
Anyway, so what we found was I just thought I'd ruin that for you. So, slightly disarticulated skeleton is clearly rotten in some marshy ground. And wonderfully, the entire lower jaw, so the skull was lying upside down, so it's lying on the top of top of its head with its teeth pointing upwards. If the lower jaw had been articulated with that, you'd be effectively looking up underneath it. But it wasn't. It was the other way up. But the teeth had fallen out. In fact, they were actually still just about attached. Now, how is that going to happen? Well, imagine if...
Did it rip its own jaw off?
Well, no. So imagine if the skull, the skull was a skull with the mouth shut and you turn it upside down and the whole thing starts to rot. The teeth are held in by a bunch of ligaments. They're going to start giving way and eventually the teeth are going to start falling out and they're going to drop out of the jaw. And then the jaw has been turned over and there are bite marks on the back of the jaw, which is where the muscles would be, which might be something that's worth eating.
So something's going to eat it when it's so decayed that it's decayed enough that it's its teeth has fallen out and is going to flip it over to do it.
Yes. Now, the other possibility, of course, is that this was just naturally disturbed in some way. But given that the rest of the skeleton was basically intact, and the only way that could more or less happen randomly is if a dinosaur kicked it or trod on it, which you think would shatter the skull or bury it or turn it over or break it. No, just the bit of the jaw with the muscles on showed marks, and the jaw had been turned up.
And Poirot cackled as he pointed at the Daspletosaurus and says,
So you did it, yeah.
There, the Daspletosaurus quickly grabbed his hat, grabbed the gun and ran out the room.
That's pretty much what we're arguing without the gun and the hat. But that's our argument. And so by using the environment and the knowledge that we've got about the burial patterns and whether or not there was a stream, and there wasn't, which is the kind of thing that might move things, and decay rates and the orientation of the bones, we can restore that. I think we made a really quite convincing case, and lots of people have said, yeah, that's...
And that Daspletosaurus is still on the run. So if it wasn't guilty, it would have turned itself in. You know, that would have happened.
Hope. But yeah, we can do some cool stuff like that.
What about poo? Oh, is that the next thing?
Yeah,
I'm guessing it's the next thing. You're going through the digestive tract.
Well, I was going to carry on actually while we were doing bite marks with the fact that it's not just, escaped ones and the Daspletosaurus. There's lots and lots of dinosaurs with bites and chunks taken out of them. It is difficult to restore exactly who was doing what to who, but that does give you an indication that there are predators out there biting stuff, and at least on occasion you can put together an argument of who it is based on the size and shape and spacing of the teeth.
I know we've got that Protoceratops and the Velociraptor physically fighting. Are there any Protoceratops with like punctures of that claw in them?
No, and it's the sort of thing that I've looked for but not found. So there's another Protoceratops that I've described fed on by a Velociraptor because there are bite marks on the bone and there are shed Velociraptor teeth. That's kind of an indication of what was going on.
Very tough Protoceratops.
Yeah, the problem with that sort of thing is it's not very likely to leave a mark on the bone, unfortunately. I'd want to do the same thing with Iguanodon. I think Iguanodon thumb spikes are mostly used for fighting other Iguanodon. And if they're wrestling each other and trying to stab each other in the chest, you'd expect to see sooner or later a punctured rib or a gouge up the side of a rib. And I've asked some colleagues who are in Belgium where the big collection is to have a look, and they've said, nah, I can't see anything. Which doesn't mean they're not doing it, but it's very annoying because I thought that'd be brilliant if we could just find a handful.
Yeah.
It'd be pretty good evidence that that's what's going on.
Loads of them, though, have got slit nostrils from picking them, so...
Yes. Yeah. And now we'll talk about poo, because that's one thing you've wanted us to talk about this entire time. So Coprolites is fossil poo. It, again, known for herbivores, but really quite rare for the exact same reasons. It's difficult for that to preserve.
Well, also, we got lots of marine Coprolites in the UK, because they're all down in Lyme Regis.
Yeah, so sharks and turtles and things are relatively easy, because again, if you think about it, as with anything else, what you need is for it to get buried. And if you're already swimming around near the bottom of the sea, it's going to come out and probably land in soft sand or something like that, and it may not take much to bury it. Whereas if you're a big herbivore out on a plain and you do that, the first rainstorm is just going to wash it away and break it up. And of course, as we know, dung beetles and flies and small animals, foxes if they were around, or anyone who was out walking their dogs. Yeah, I know. So it's quite hard actually for that stuff to get buried. And even if they were on a floodplain, even if they were wading across a river, the equivalent of a cowpat, it doesn't survive dropping into water. It just disintegrates instantly.
But we've got that Tyrannosaurus rex splat.
But herbivore ones are rare, though we do have a handful of them. But yeah, there's the Tyrannosaur one. And again, at least part of the reason that's preserved is it's full of chunks of bone, which is very good at preserving compared to chewed leaves, which are not. And in that case, the bone is really, it's very interesting. I've written a bit about that specimen, though I've still never seen it myself. Because if you look at some things, so this is an argument that I made in a paper with my postdoc supervisor, Ollie Rauhut, that tyrannosaurs are perhaps not the super bone digesters that people think they are. There's this idea that, the bone crunching teeth and jaw, and they smash carcasses to bits and swallow everything. And we went, actually, no, they're probably not. Because if you look at
that's the little arms, isn't it, Dave? The little cutlery.
Yeah.
Just tearing them up very gently and then eating select morsels.
But if you look at animals that do that, so things like big crocodiles, things like Egyptian vultures are not big birds. Obviously compared to living birds, Egyptian vultures are pretty big, but they're small even by vulture standards. And compared to, again, a multiple ton T-Rex, they're basically tiny. What they put out at the back end is basically a bone slurry. You will will struggle to identify any real bone fragment. The acid has really got to it and just made a complete mess of it. The bones in the T-Rex coprolite are from a juvenile dinosaur. They're from a young hadrosaur, which some people will know or remember. Juveniles don't have fully ossified bones. They're actually quite a lot more bendy. They're not as stiff, so they don't have as much real bone to them for their size as an adult.
So they'd be like an Alka-Seltzer in water inside a vulture.
Well, not quite. But, they're just not that tough. They've been processed by a full-size, as far as we can tell, T-Rex, and then been through its digestive tract. If an Egyptian vulture, a bird which is little more than knee-high to me, can eat a decent-sized bone, and they do, they'll swallow lamb chop bones and things like this, and, nothing comes out the other end. If they can dissolve a bone that big from their size, a T-Rex which has bitten the bone into pieces and then gone through that giant gut, there should be nothing. Absolutely nothing. And instead, we can pull the fragments out, enough of them to reconstruct which species it ate. This suggests that they do not have some incredible super digestive system which can just dissolve whole Triceratops hordes, which I think some people think they can.
Or that was a very ill T-Rex which then later died.
It's certainly possible. Again, the going back to the earlier point, you don't want to over-extrapolate from single points. But even if it was, if it was that sick that it ate, so the coprolite has been described as being a bit splattery. We don't know if that's normal. Maybe it was ill. Maybe it drank a lot. Who knows? Maybe it dropped it into water, which made it splat. But if it was that sick, it would probably throw up.
That's
so it has gone through to a certain level.
This is theropods we're talking.
Mostly.
So are they like modern birds? Because modern birds mix everything up in one deposit, as it were.
Yeah, so that's an obvious question, and different birds do different things, and indeed crocodiles and lizards do different things. So yes, some still have something that approximates urine as well as having something that's feces, and others produce some kind of combi slurry.
Combi slurry.
I've seen both argued for. The standard answer, of course, is there's at least 1,500 species of dinosaurs. They're around for 165 million years on 7 continents and in every known environment.
I need to know how much loo paper they need.
Yes, different dinosaurs are going to be doing different things, and it's very unlikely they're all.
All right, but is it good for the roses? Is it like chicken compost? Is it?
Well, again, herbivores and carnivores are doing different things. Meat is relatively easy to digest. As someone who worked at London Zoo behind antelope, giraffe, rhino.
It does sound like the start of the sentence. You are eating all of these things.
Yeah. They eat a lot of stuff, and they produce a lot of stuff. For a while when I was at London Zoo, we were short-staffed, and they used to send someone over from the lion of the big cat section of the zoo. And once one of my friends went back the other way, and I went, this is something, this is like, 25 years ago now. I don't think anyone at the zoo is still there. And London Zoo has changed massively since then. But it was always a bone of contention that there were about, I think, 6 or 8 permanent keepers for what was the giraffe and antelope section, and something like 5 for the big cats. And we're like, but all our animals are much bigger and have bigger areas and eat tons of food every day and produce loads. And you give the tigers a food once every 2 or 3 days. Like, why are we working so hard? And yeah, one of our guys went over to the lion house once to cover when someone was ill. We came and went, what was it like? And he went, mate, I can only drink so much tea in a day. In other words, they just sat around drinking tea, because oddly enough, slinging a horse carcass over a fence and then picking up 1 shovel of poo a week later was not a huge amount of work, even for the lions and tigers and leopards and sandcats.
It works with humans too. Before Second World War, there was rationing going on in Britain because the Germans were doing an amazing job with their U-boats in the Atlantic, and we had 70...
May not be the most sensitive way of putting that for some people.
They were. It was Dönitz. He was an amazing commander, and he was sinking all of the British shipping pretty much, and 70% of our food came from overseas. So the British government were doing their best, and they were trying to work out how they could replace all this meat that couldn't make it across, and all this protein, like eggs and stuff, couldn't make it across. How are we going to replace that? And they worked out on a more vegetarian diet, and they worked out the amount of food everybody needs. They did specify that you can get away with eating, I think it's 3,500 calories in vegetation for a labourer will work, except they will need, I think it was 65% more loo breaks and And they become very flatulent. So the flatulence goes through the roof. So,
So it saves on the heating, though, if you've got the candles lit. So
exactly, it's fine. Just underground, dangerous. But yeah, so it is a factor when you're considering being a vegetarian. You will be sat on the loo for a bit longer.
Yes.
In summary, Dave, from starting at the teeth all the way down to the poo, that is how you're working out. Aren't you looking at sort of available foods and landscapes?
Well, yeah, there's other things as well, of course, going into that. I mean, so yeah, we're looking at other things as well. Obviously, Tyrannosaurus mostly lived in an environment that had no sauropods in it, or very, very rarely had sauropods in it, so it's probably not eating much sauropod. Things like that are going on. But, I mean, one thing it's worth remembering, which we've definitely talked about before, is, the bigger something is, the harder it is for that thing to be some kind of specialist and focus on one type of food. I constantly see people arguing that, like, T-Rex or Tyrannosaurs were hadrosaur specialists because there were lots of hadrosaurs around. It's like, no, they would have eaten absolutely anything they could get their mouths around. I remember a really cool study done years and years and years ago. I'm sure it was so old that there were flaws with it, but the big argument about were zebra stripes putting lions off, was it an anti-predator defense? And someone basically did a big survey of lion diets in a bunch of different locations, and they basically found that lions eat other animals, elephant, everything, elephant, rhino, hippo, buffalo, all the way down to
people.
Well, yeah, but except all the way down to relatively small things like warthogs, basically in proportion to how common they are. If 20% of your herbivores are zebras, lions eat 20% zebra. If it's 10% zebra, they eat 10% zebra. And this was designed to solve this question and go, well, look, it clearly has no effect on their choice of zebras as a prey item at all.
No, but it would make it harder to select the zebra from the pack. So it makes sense for zebras to be striped. Because
if they found zebras harder to hunt than other things, they would not hunt them as often. If they were a harder thing to bring down,
but it's more about standing out from the herd, isn't it? Rather than so the lions find the zebra stripes slightly confusing because it's hard to separate the zebras. Well,
from
each other.
That's the point.
Okay, but isn't it easy to see the zebras and then go, oh, there's a weird looking one, I'll have that one, because that one's one that stands out from the herd despite its stripes, rather than it's just a way of zebras protecting themselves.
So weird looking zebras, and we've had another black one born recently, or one that's almost predominantly black with just some white spots. They tend to get socially ostracized from the group, which is a different kettle of fish. That's making them artificially vulnerable, but stripes as a whole.
Zebras are mean.
Yeah, they are. There's lots of factors going into it, but yeah, in general, big things are going to be eating just about everything that they can. Small things can be selective. Mouth width, we absolutely know correlates with selectivity for herbivores, for example, which also often correlates with size, which also then often correlates with social structure.
Wow.
And herding behaviour, which is really quite neat. But we're not going into that right now.
No, we're
That's
not.
going into the next book.
Ooh.
The book which is hilariously behind, so I've only just finished the last one, which is hilariously behind.
What's it called?
The Future of Dinosaurs. Or in America, it's being called How Fast Could T-Rex Run, even though that makes up about 4 lines of book.
T-Rex can't run. They walk.
I wasn't overly happy with the English title. I'm really not happy with the American one. That's what the publishers want. That's what it's going to be sold as. And they paid me anyway, so I couldn't roam too much.
Fair enough.
That's what happens when you sign the rights over.
We will be back next week. In the meantime, please do visit terriblelizards.co.uk. Do go to our patrons and sponsor us on Patreon. It is basically the reason we do this podcast. You are absolutely wonderful, you patrons of dreams. And thank you so much. And you can message us, obviously, on there, or you can email terriblelizardspod@gmail.com. Until next week, Dave, what do we say?
Raw.
Oh, that was rubbish.
I know, I thought I'd ruin it.
Don't ruin stuff. We could do the sort of raw that a very uncomfortable Coprolites production would... No, okay, let's not do that. Let's just normal raw.
I'm just laughing. Is this going to make it in?
Of course it will.
Lovely.
After 3, 1, 2, 3... David.
I thought we were doing the Coprolite raw.
You are a doctor. How are you going to make it a professor if you do that? Thank you for listening to the Terrible Lizards podcast. To support the show, share this episode and leave us a review, especially with dinosaur emojis, on your app of choice. You can also become a patron on patreon.com/Terrible Lizards, where you will be rewarded with extra content. For more information about Dave and Izzy and our books, other podcasts and blogs, please visit terriblelizards.co.uk. We hope to keep making this content, and it's down to your support that we do, so thank you.